All right, so we are making progress here. We're up to chapter 8 already. All right. Now, depending on how things go, because I don't know, but like I said, tomorrow, and just so you know, tomorrow we will have a visitor in here. You may or may not know this, but every month or two, they run what's called Shadow a Tech in here. So we've got a prospective student who's going to be coming in here tomorrow. And since good, bad, or indifferent, probably the most outgoing and gregarious person in this room is Gabriel. I'm going to ask that he sit next to you if that's okay, and kind of watch what you're doing. That's one of the reasons we're going to be building these applications together so that she or he, I don't have any idea, I just was told there'd be a student. Now, last time we were supposed to have a student, they didn't show. You know, if it would be today with the weather and that, maybe they wouldn't show. I have no idea. All right. My wife was all mad that we actually had class today because I guess that Wentzville is, their whole school system is closed. Not here. That's okay. All right. But let's start going over chapter 8. Now, one thing I wanted to mention to you, if you haven't seen this before, so this is mainly for those of you who might still be struggling in this class. All right. If I go out to w3schools.com, which is a site I referenced a lot last semester, and I find tutorials, they have tutorials on a lot of different things, including learning C#. All right. So just to show you this, there it is. And is it good? I don't know. I've looked at it and it's okay. But again, especially if you're looking for, if you're struggling or whatever, and you're looking for any resource you can find, you can go out to w3schools.com/CS for C#. All right. The reason that I mention that is, in my opinion, good, bad, or indifferent, what we're about to do with arrays is the hardest thing we've done this semester. All right. You may or may not agree with that as we're working our way through it. And as soon as you go, well, that wasn't that bad. All right. Then we go from arrays to array lists, which are harder than arrays. And if you say, well, what does that mean? That's what today's lecture is about. All right. It is 8:36. I'm going to go till about 8:55. Then I'm going to give you a break. Then we're going to come back in and we're going to finish this. All right. Ideally, we'll finish the lecture no later than 10 and maybe a lot earlier than that. The rest of the period then is lab. And if you came in late and didn't hear this, again, I have graded, as far as I can tell, everything that people have turned in through chapter 5. If you are one of the 1 or 2 people in here who turned in 6 and 7, I didn't grade them yet. All right. And remember, you don't have to do, earlier I'd been doing those homeworks, you just have to do the labs. All right. So, but you are expected to do all of those labs. You will, yes.
Yeah. So after we're done with all this, I turned in 4 and 5, but I got a 0 on it.
You turned in 4 and 5 homework. You didn't turn in the 4 and 5 labs.
I uploaded that.
Well, I didn't see them in there.
Okay. Well,
So if they're there, then just let me know, and I'll go back and regrade it. That's fine. All right. And if you got a 0, it's because I didn't see anything there. It's not because, yeah, I don't like you, I'm giving you 0. No, it's because I didn't see anything out there. That's why. All right. And there were some people who got 25 out of 25, and guess what? You may have been missing something, but basically you did it correctly. You had the right idea, etc. All right. Okay. So let's jump into the chapter then. Whoops. I'm going to go here. So arrays and collections. It says they are objects that you can use as containers. And with the people who were in the class last semester, I'm going to give an analogy right now, which may be okay and may not be that okay, but you may have heard it last semester. Now, when I was a little kid, you didn't have Legos, okay? You had Tinker Toys. Maybe you know what Tinker Toys are, maybe you don't. But basically, they're probably not great toys for little kids because they're sticks, and they're like little round things that have holes in them where you can put the sticks in different ways. All right? Kind of have been replaced today with more politically correct Legos. But regardless, let's just use the Tinker Toy analogy. So it's the first day of class. And let's just assume, because I actually had a class like this when I was at the University of Wisconsin-Milwaukee. I took a child psychology class. I was in a lecture hall with 250 other people. First day of class, we walked in there. No joke. I had worked till 3:30 that morning, went home, and then came to my 8 o'clock class. So as you can imagine, I wasn't in that great a mood, and I wasn't that awake. There was one window in the room that wasn't open, and the door was shut, and it was 90 degrees. All right. And to be honest with you, I fell asleep. When I did, I dropped my pencil, and it rolled all the way up to the, or pen, it rolled all the way up to the front, and they woke up. They woke me up. The instructor had them wake me up. And I'm not going to lie to you, I was a smart ass. Probably in some ways I still am. And he said, am I boring you? And I said, no, but if it wasn't so effing hot in here, maybe I wouldn't have fallen asleep. And I didn't say effing. All right. And he was kind of surprised. He didn't kick me out or anything. He talked to me afterwards. He said, you really shouldn't use that kind of language in here. I said, I'm sorry. I said, I'm not used to being in a 90-degree room with 250 people with no ventilation. All right. And he agreed. The point is, imagine that that when he came into that class, he was late that day. Okay. So what he did was he brought one of his teaching assistants in. And these teaching assistants, they gave each one of us either one of these little round things or a stick. And they said, he'll be here in a half an hour, have fun. All right, let's face it, especially if you got the stick, there's not that much you can do with it. You could twirl it around, you could do it, but there's not that much. Even the round thing, there's not all that much you can do with it. But you start talking to the person next to you and you say, I got this stick, you got a round thing, and they got a round thing, let's build something. All right, maybe if the instructor did that, that was why he did it. Because he was hoping we'd build something. The point is, those individual little things, that an individual stick or an individual little round thing, that's what we've been working with thus far. They're called elementary data items or primitive data items. So, in other words, if we had age, age could hold 34, age could hold 10, age could hold 73, but it only holds one value at a time. What we're going to get into now are going to be collections of elementary data items. And those collections are going to be called, at least to start with, an array. Now, unlike what you guys had last semester in JavaScript, since C# is what's referred to as a strongly typed language, I can create an array of numbers like integers, but that's all I can put in them as integers. I can create an array of Booleans. I can create an array of doubles. I can create an array of strings. Do you get the idea? But they all have to be the same type of data. Now, last semester when these guys were in the JavaScript class, we talked about arrays, but they don't all have to be the same data type. That's because JavaScript is not a strongly typed language. C# is. All right. So they call an array that's something that acts like a container, so it can hold multiple things. All right. One thing about an array in this language, again, unlike JavaScript, if I create an array, so let's say in here I created an array that I was going to call test scores, and there's 7 of you in the class, so I made it size 7. Now, let's suppose it's the second week of class and somebody new gets added to the class. I have to stop the program run and manually go in and change the number of students from 7 to 8. Does that make sense? I can't just, while the program's running, like you can do in JavaScript, just add another element to the array. You can't do that here. So arrays are fixed in size. And actually, arrays in this language are what are known as early binded. What that means is when the compiler, the thing that's going to try to take your program and convert it into the ones and zeros the computer can understand, when the compiler starts to run, it needs to know exactly how much space to allocate for the array. And what does that mean? That means that if for example, if integers take 8 bytes, and we say that the array has got 10 integers, that's 80 bytes. Do the math. All right. So it says, as you develop C# applications, you'll find many uses for arrays and collections. That's true. Not only that, if you think about it, when we've talked about loops, We talked about a while loop, we talked about a do while loop, and we talked about a for loop. And one of the things, hopefully you remember, and hopefully I said this, when we talked about a for loop, as I said, a for loop is a counting loop. You need to know exactly how many times you're going through it. Bottom line is this: for loops and arrays go together. All right. The other night, Forrest Gump was on, and I just was turning the channels, and it was where he said him and Jenny go together like peas and carrots. Well, that's arrays and for loops. They work very well with one another because an array is a fixed size. So as you step through an array, quite often you'll use a for loop. It just makes sense to do that. All right. It says you can use that array or collection to perform calculations on whatever's in there. In this chapter, we learn the basic concepts and techniques for working with arrays and other collections. So we start small with single dimension arrays. What does that mean? Well, I'll give you another bad analogy. All right. Years ago, when I moved here 5 years ago, all right, my wife did not move with me. My kids did not move with me. I had one daughter living here already, but my wife and two kids stayed in Illinois. So I got an apartment where I lived in by myself for 2 years. And as you can imagine, and this isn't great, it was an 8-family unit. All right. So if you can imagine that these are the families that are there. I just made this up. I have no idea who the families were. I never met anybody who were my neighbors except the guy right across from me because someone broke into his house one night. That was the only reason I ever met a neighbor. All right. The point is, if you can imagine, I lived in apartment 1, Jones lived in apartment 2, etc., as you can see here. All right. Chances are usually pretty good in most apartments that if you put on the mailbox, if you've got the person's name, that if somebody were to just have sent something to 123 Main Street and it had Scott on there for a last name, typically at least, the mail person is smart enough that they would have put it to the right apartment. Now, what happened there a lot was people would peel stuff off, somebody would move, it would fall off because the stuff they put up there was cheap, etc. And I was constantly getting other people's mail, all right, even though typically it had the right apartment number on it, etc. But the point is, if you look at each one of these as a location, all right, then what we could say is, let's just say we call this whole thing apartment. So we could say something like apartment 1 equals Scott. Apartment 2 equals Jones, etc. Does that make sense? So we could set up an array of strings if we wanted to that we called apartments and did something like this. And that's pretty much how arrays work with one exception. Because we're working with computers, the first element that's in there is not element 1. The first element that's in there is actually element 0. So this array that you see right here has 8 elements in it, and they go from element 0 to element 7. All right? When you create an array and use an array, you use these brackets like that are shown right here. This right here would be a way that we could create a brand new array that would hold integers, all right, and it would have enough space in it for 8 grades. So then below that, I have filled it with 8 grades, and I did them one at a time. So literally where there's a 0 here, that would be the equivalent of 67, 97, 88, 100, etc. All right. So I can create an empty array and then fill it in, or if I want to, if I know what it is to begin with, I can pre-fill it like this. But I have to let the system know that it's an array with bracket, bracket. And if I'm going to pre-fill it like this, it has to be within curly braces. So there are certain things that you have to follow as far as the syntax for this. And I'm not saying, did you understand that? Because if you don't, it's just not going to work. All right. So that was just a real little intro on this. All right. So we're going to start with, and that what I was just showing you was a one-dimensional array. And I just showed you how to create one. I just showed you how to assign the values to it. That's it. Now, what if in this example here, what if I wanted to print out these grades? Are you with me? What if I wanted to print out these grades? Well, I could do a lot of ways, but the easiest way would be like this, and it may look a little funky at first, so bear with me. I'm going to say for int LCV for loop control variable equals 0. LCV, I can say less than 8, but I don't like to say that. I like to use the name of the array, grades dot length. That's how many elements are in it. Plus plus LCV. And then all I'm going to do is just print out those grades, period. So I'm just going to say message box dot show. Now, I want the current grade, so it's grades LCV. And sometimes that confuses people. All LCV is in there. I could have called it X or Y or Z or whatever. It's just the current grade. So the first time through, this is going to print out what's in grades 0, which is 67. Then we add 1 to it, and it'll print out what's in grades 1, which is 97, etc. We could do this using a while loop. We could do this using a do-while loop. You very rarely see that if you are going to take the time and the effort to do something like this with an array, it's almost always done with a for loop. It's not that it has to be, but it just results in less code. All right. So let's go through this first section, and we're taking a break. So to create a one-dimensional array, it's what I just showed you. So it's the same syntax. And they're going to show you 2 ways of doing it. Guess what? I've shown you both. All right. It says when you create an array, each element in the array is initialized to a default value. What does that mean? That means if you look at this example, this right here, each value automatically has 0 in it by default. You don't have to initialize them to 0. If I wanted to make sure they were all 0, I could have come in here and done this. That would set every one of those to 0. But the system does that for me automatically. So numeric arrays are always preset to 0. Boolean arrays are preset to false. String arrays are preset to the empty string. All right, so you don't have to do that, which is kind of nice. So they're showing examples here. There's a decimal array. And again, so decimal will have decimals, totals 0, totals 1, totals 2, and totals 3. That should make sense to all of you. All right, so here's what I mentioned. So an array, every single thing that you put inside of the array is called an array element. So in the example that I showed you, this array has 8 elements in it. The thing that's right here, this 0, this 1, this 2, this 3, etc., those are called indexes. They're also called subscripts or subs. Typically, the way you would read this is grades sub 0 equals 67. Grades sub 1 equals 97. That's usually the way you'll see that read. All right. And again, all those values, those are just, just imagine that instead of coming in here and saying test 1, test 2, test 3, with 7 of them, now it's going to be tests sub 0, tests sub 1, etc. What's the advantage of doing that? It's much easier to work with an array of values in a loop as opposed to working with individual values within a loop. All right, so it's brevity amongst other things. So they show some examples in here, again, empty, and here they're setting it up one at a time. Here they're, again, they've come in and they've said, look, now look at the differences here. You can say decimal bracket bracket totals equal new decimal 4 and then put the curlies in. I have never in my life seen it done like that because these two things do exactly the same thing. Why you would include new decimal like they do in the first one is way beyond me. But you can do it if you want to. That's the point. Now it says to refer to the elements in an array, you use an index where 0 is the first element. So the upper bounds of the array, in the example I showed you, there were 8 elements, but the upper bound was 7. Does that make sense? All right. And there are a lot of built-in methods that you can use with arrays, which makes them really nice to work with. You'll see some of those already tomorrow. All right. If you specify an index that's less than 0 or greater than the upper bound of the array. So in other words, in the example I showed you, if I'd said it here, grades -1 or grades 55, you get an exception, and it's called an index out of range exception that will get thrown automatically. All right. So if you look in here, what are they showing? Well, a couple things. First of all, I guess I had length should have been a capital L, and I think I made it a lowercase. So that should be a capital L. Every language is different, so that should be like that. All right. But they're showing here how you can loop through the things that are in an array, how you can go through and put what's in an array. What we're going to do tomorrow, and we're going to do it 3 times. First, we're going to write a console app. And what we're going to do is we're going to create an array of 25 random numbers. And then we're going to print out a bunch of stats about them. The highest, the lowest. We're going to put it in ascending order. We're going to put it in descending order. All this stuff. Then we're going to do the same thing. And what I'm going to do is I'm going to literally put my picture, when I say my picture, I don't mean of me, but the picture of my program on the board, and I'm going to ask you to build that interface. And then we're going to work with that. We're going to do the same kind of thing, but we're going to do it in a GUI manner. And we're also going to set it up so that you're going to be able to say, hey, if I wanted to search that array for a value, how would I do that? So I'll show you how to search the array. All right, so we'll go through all of that tomorrow. All right, before we go on how to use for each, it's 8:56. Let's come back, please, at 9:06. All right, I'm going to continue on, so I'm on page 222. How to use for each loops to work with arrays. And a for each loop is basically, you can actually work with for loops. A for each loop is meant to work with a collection, like an array. There are other collections that we'll talk about as we go on in here, but you oftentimes use them with an array. Why? Well, notice in here, it's even less code. So what is this doing right here? Well, the first thing to realize is you've got an array, and you've got an array that's called numbers. And what they're doing here is they're creating a local variable right in here that's called number. So quite often, if you're going to use a for each loop in your program, whatever your name of your array is, you'll pluralize it. You'll put an S on the end. And then if you use a for each with it, you'll have the same name, but singular, without the S. Number in numbers, box in boxes type of thing. All right? And this, we could have written this as a regular for loop, but it just would have been a little longer. In here, you don't have to tell it to keep going. You do the plus, and you don't have to make a check in here to see when it ends. So it results in less code. So notice if you look in here, here's a for each loop that'll figure out a sum. And this is the whole loop right here. That decimal average is not part of the loop. So you end up writing even less code. If you say that's confusing, then don't use it. Just use a regular for loop. You'll be writing more code. It'll actually run a little slower. The for each has been optimized to run faster. All right, but it's okay. Again, be programming for understandability. So as it says, you can use a for each loop to access each element in an array. That's an important point. The for each assumes you're working with every element in the array. Are you with me? So let's say we had the numbers from 0 to 100, and we only wanted to work with the even numbers. Then you don't use a for each. You have to use a regular for loop, because with a for each, It just adds 1 to it every time. So it's assuming you're working with every element in the array. All right. How to work with a rectangular array, also known as a two-dimensional array. What's the difference? Well, I'm asking you this question, and if I'm wrong, please let me know. Let's see. Has everybody worked with some version of Excel or something like that? Am I right in assuming you've at least seen a spreadsheet? Is that a fair assumption? Even if you've never done a thing with them. All right, but if you've seen them, that's a two-dimensional array. Now, this right here, it says A1. What does that mean? That means I'm in column A, row 1. All right. If you were saying this, if we made this into a C# array, this would be location 0, 0. And when you do it with two things like that, the row is always first. So it would be row 0, column 0. This would be row 0, column 1, row 0, column 2, row 1, column 0, etc. Does that make sense? All right. You can have an arrays of as many dimensions as you want. You know, years ago, and maybe I told you guys this last semester, I thought it was funny, but it wasn't, because I have a weird sense of humor, I guess. But we were talking about arrays in one of the classes, and I had shown them examples, and I'd even drawn, as best I could, a three-dimensional array. And then I said, for your homework tonight, I want you to make and add another dimension, and I want you to draw a four-dimensional array for me. Well, you can't draw in 4 dimensions, but people tried. All right, I had a couple people come up to me the next day. I tried doing this homework, man. I just didn't have no idea what you were looking for. I wasn't looking for anything. It was supposed to be it was a joke, but it was a bad one. But the point is, when you're working with arrays, they can be as many dimensions as you would like. It's very rare that you will see an array of more than 3 dimensions. Because again, if you can't kind of see it, as they say, in your mind's eye, if you can't conceptualize it, most people don't want to use it in a program. All right. So notice in here, int bracket bracket. What the heck does that mean? This means that if you are going to create an array and it's 2-dimensional, you need to put that comma in there, because if you don't, it thinks it's a 1-dimensional array. And then row column, row column, row column. So this is a 3 by 2. All right. So it's got 3 rows and 2 columns. All right. And again, you can set them up. These are numeric. Here's a string, etc. But you cannot have like numbers and strings. They all have to be the same data type, even if it's a multi-dimensional array. Now, when you've got the same number of rows and the same number of columns throughout, that's called a rectangular array. Why? Because again, it looks like this. It's a rectangle, but you don't even have to do that. In other words, I could make something that had maybe this many rows, and then with the columns, there I had 4 columns, and the next one I have 3, and the next one I have 2, etc. That's called a jagged edge array. You can do it either way. Why would you maybe want to do that? Well, maybe you're getting information about people at a company, and you might have somebody who's worked there for many years, and you know all their information, and you might have somebody else that just got hired, and you don't have all their information, as an example. So as it says, a rectangular array uses 2 indexes or indices to store data. You can think of this as a table that has rows and columns. It's always done in row column order. So years ago, I had somebody say to me, well, if I wanted to do it in column row order, can I? And yeah, you can. You're going to confuse the hell out of anybody who uses your application, but yeah, you can. All right. As it says, although it's rarely necessary, you can extend the 2-dimension to work with arrays of as many dimensions as you want to or need to. So they show some examples in here. All right. Notice that when you are working and you're going row column, the rows are in the outside for loop, the columns are on the inside for loop. So imagine we had an 8 by 10 array, so 8 rows, 10 columns. Then it would be 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 1, 0, 1, 1, 1, 2, etc. All right. And again, they give you some examples of it here. Now, it says here you can use the getLength method to get the number of rows or columns in a rectangular array. Again, always starting at 0. You use nested for loops to iterate through the rows and columns of an array. All right, one of the things, and I could show it to you right now, it wouldn't take very long, but if we wanted to write our own clock, we could have on the outside, we could have hours, then inside it with a for loop that went from 0 to 23, I'm assuming military time. Then we could have a for loop inside of that first for loop for minutes, and that would go from 0 to 59. And then inside of that inner for loop, we'd have another inner for loop inside of that one for seconds that would go from 0 to 59. And you literally can write a clock that would go from 0, 0, 0, 0, 0, 0 to 23, 59, 59 in about a dozen lines of code. All right. So jagged arrays, I already mentioned. As it says, it lets you store data in a table that can have rows of unequal length. Some people really hate this. They find it really confusing. All right. I'd say that when right now, I don't believe you're going to have any homework with them. I don't believe you're going to have any test with them. But the key thing is they exist. There may be a very good, valid reason for using them. All right. So as they mentioned on the bottom, you can use jagged arrays to store data in a table that has rows of unequal length. It's also known as an array of arrays. And they will show you some examples of doing that as well. So you'll notice here, the first row has 3 columns, the second row has 4 columns, the third row has 2 columns. Totally legit. As it says, since the number of columns in each row of the jagged array varies, you cannot use the getLength to get the length of a row. Rather, you use the length property. Now, just so you know, too, because it bleeds right into what we're getting into here, but if I go out here and I type in, for example, CSharp arrays, all right, and one of the first things that comes up is docs.microsoft.com on CSharp, and they'll have arrays. There are a boatload of methods that exist for arrays. We're going to look at some of them tomorrow. You can write your own to be able to manipulate an array as well. All right. It says because an array is actually an instance of an array class, you can use the properties and methods to work with it. Okay. So here's some of the ones. The most common property you're going to use is the length with a single dimensioned array. I already showed you that. So rather than saying, like x or whatever you're using equals 0, x less than or equal to 10, you say x equals 0, x less than the name of the array dot length. That's just the way you do it. That's the way I will expect you to do it because that's the way you should do it. All right. Now notice there's other things too. There's some get methods to get upper bounds, etc. There's a copy method. It says copy some or all of the values from one array to another one. And they're going to talk about it a little bit more coming up. That's really pretty important. Because if you have an array with 1 million elements in it, I mean, you can do something like this. You've done this already. Or I can be writing a program and I can say, let x equal 17. Not let, sorry. Int x equals 17. And then I could say int y equal x. Not a big thing. You've done stuff like that before. But imagine it was an array with 1 million elements in it. You can't create an array with 1 million elements in it and just sit there and say, now I've set this other array equal to the first one. But you can use the copy operator. In the past, you had to write a big loop and copy everything over one at a time, which could be a pain in the butt. It could really slow down processing time. Arrays have a sort method, which sorts stuff into ascending order. All right. Also, notice it has a binary search. We're going to use this tomorrow. And maybe I gave you guys this example last year, but it's true. I'll always remember this. Many years ago during the summer, when I was working at the technical college in Wisconsin, we didn't have to go in the summer. I typically would go in every other day, but you didn't have to, period. Well, one day I was at home watching TV, and it was the old Price is Right show. How long ago it was, Bob Barker was still the host. So it was many years ago. But he brought a guy up, and he won whatever it was to get up on the stage, and he had a minute to guess the price of a refrigerator freezer. Okay? And he said, $700. And Bob Barker said, higher. And he goes, 701. And I'm thinking, you ain't going to win. You know, he had 60 seconds. You know, so again, I don't know if we did this last semester or if we'll do it in here, but one of the programs I oftentimes have people do in this program is to do a guessing game program, where you'll have a computer generate a random number between 1 and 100, and then you'll guess. So I guess 30, and it says higher. Well, I should already know then that the first 30 numbers are out of range. It can't be one of those. So typically you say 50. And if it says higher, now you've thrown half the numbers out. I say 75 and it says higher. Now I've thrown 3/4 of the numbers out. So I say 87 and it says higher. So in 3 guesses, I know it's got to be one of 12 numbers. That kind of thing. So why is that important? Because you can search for values that are in an array in kind of the same way. In other words, if I put an array and I'm just going to throw in 5 random numbers, if I sort them, 34, 56, 71, 112, and 200. And if somebody says to me, is 83 in here? You can look at it and know that it's not. I get that. You're not the computer. So what you do is you look in here. And you say, is that the number? In the best case, that's the number, right? I mean, one guess, I guessed it. It's like playing that guessing game and having the number be 50 and having me guess 50. Not going to happen often, but it could. Nope, not there. Okay, is it higher or lower? It's higher. So I know it can't be any of those. All right. There's only 2 left, so I'll just check the next number. Is it higher or lower? It's lower. It can't be in there. All right. That's what's called a binary search. It's also called a halving, Halving search. That's what we're going to do tomorrow. All right. One of the things that we're going to do tomorrow. And as it says, the binary search only works on arrays that have been sorted into ascending order. When we do this program tomorrow and we generate 25 random numbers, it's possible we'll have the same number generated more than once. We could check for that. And if we got the same number again, we could just say, then do it again. But we're not going to do that. All right. As it says, because arrays are created from a class, they are reference types. What does that mean? That means that when you pass an array in, if you pass it into a method, it's automatically passed by address. So if you make changes to it in the method, they're permanent changes. All right? It says once you declare an array, it can't grow or shrink. It's immutable. That doesn't mean what's inside of it can't change, but the array itself, the size of the array cannot change, but the contents that are inside can change. All right. It says here, if you want to create a copy of an array, you can use the copy method of the array class that's shown in there. It says you can use the two techniques to copy the elements in an array. First, you can copy one or more of the elements starting with the first by specifying the source array, the target, and the number to be copied. All right, you can also copy it, as it says, copy one or more elements of an array starting with an element other than the first. So you can copy an entire array or part of an array. And they show examples of doing it right here. All right. So doing this is literally telling it to copy everything from one array into another array. All right, which is really nice. So how to code methods that work with arrays. Let's just jump into here. So some of these things are going to be real simple. I showed you the example from the test before when I checked to see if I had a new largest test score or smallest test score. And guess what? I'm going to be doing the same exact kind of code tomorrow to find the largest number in the array or the smallest number in the array. All right? But it's even easier than that. If I have an array of 1,000,000 numbers, would you agree that I could go through the entire array 1,000,000 times and find the biggest number or the smallest number? Would you agree with that? But couldn't I also sort the array and then the one that was element 0 was my smallest number automatically? All right, there's also a reverse sort. So that would give my biggest number then would be the biggest, the first number would be the biggest in the array. And you're going to see both of these tomorrow. So you can write a little code, and what's the saying? You can get a lot of bang for a little buck. All right. Okay. If you pass an array into a method, you just give it the name of the array. But in the array itself, you've got to tell the type it is and bracket, bracket. Don't put the size in there, but bracket, bracket, meaning that you're working with an array. All right. So they talk in here about the params. It says to accept an array as a parameter of a method, you code a set of brackets after the parameter type to indicate that the parameter is an array. By default, arrays are passed by reference. It's what I mentioned to you before. They're passed by address. It says if you want to pass 2 or more arguments that haven't been grouped into an array, but have them be treated as though they are an array, you can use the params keyword. If you go, I looked at that and that's really confusing. Don't use it. All right. You should be able to get through this entire class without ever having to use that. All right. CSharp 2015, and remember we're in 2019 now, but 2015 is when they started having something called the null conditional operator. As it says, it makes it easier to test for null values in objects like arrays. And you're going to see it on the next page. Why would you do that? Because if you don't check and something's null, remember this from the test? You can get a null reference error. All right. And the way it's done in here is very similar to stuff we've looked at before. You could put that question mark in there. That question mark basically sends a signal that either you will or will not allow the usage of nulls. Remember, null is unknown. Right now, if the 3 of you started this semester, if you have not taken any classes previous to this one, your GPA is null. It's not 0. You don't have one right now. It's unknown. It would be null, and that's how it actually should be shown in a database. The rest of you took classes last semester with me and or with me, but possibly also some gen eds. So you do have GPAs. So as it says, one way to prevent a null reference is to use an if to check for null values. An easier way is to use the null conditional operator, the question mark. It checks the object or element that precedes it for a null value. If it finds null, it basically doesn't do anything else. All right. All right. Now, either you got that or you didn't get that. Either that made some sense, it made a little sense, it made a lot of sense. All right. But the one thing about arrays that I guess aren't that good is they're fixed in size in this language. In languages like CSharp and in languages like JavaScript and PHP, arrays can change size as the program's running. Not in this language. Not in the language that we'll be using in the 4th semester. All right, in Java, they're done the same way as they are here. Okay? But, and rather than working with an array, if you work with what's called an array list is a different type of collection that can expand and contract as the program's running. So whereas arrays are what are called early binded, which means at compile time, the system needs to know how much room to set aside for it. Other collections, like array lists, are what are called late binded. So they don't figure out how much time they need until the program's running, which means as the program's running, they can change size. I mean, they're more reminiscent of real life. So if I was creating, let's just assume that I'm working for a company and they're having me create a whole payroll program for them. It's a brand new company. We have 100 employees. If I make an array and I make it size 100, what am I going to do when we start adding new employees? I'm going to have to constantly be changing that value. But if I make it an array list, I can literally start with 0 and just add as many as I want whenever I want to. So in other words, they're mutable, which means you can change the number that are in there. As it says, they're usually more appropriate and manage system resources better than arrays. All right. So imagine, I've given you this type of example before, that if I had 3 classes, and let's say I had 500 people in one class, 100 people in another class, and a discussion group of 10 in another class. If I wanted to be able to handle all of them, and I used an array, I'd have to make it 500 to handle my biggest class. Well, that would be wasting 490 for the class with only 10 in there. All right. Okay. So it says prior to .NET 2.0, and we're in like 4.2, so that's been a while, the collection classes could store any type of object. As a result, collections created for these were sometimes called untyped. Okay? It says, however, if you accidentally write code that adds the wrong type of object, it'll result in an error. So in other words, the good news about it is that you didn't have to worry about the type of data you were using. The bad news is, if you tried doing something you shouldn't do with that type of data, the program blew up. Okay? So it says that starting in .NET 2.0, they had a new feature that were called generics that allowed you to use type collections. It's not that this is hard, it's just that this uses a different syntax. So what you're going to see on the next page is it's going to look different than what we've been working with previously. With arrays, you use brackets. All right? With generics, you use, it looks like an HTML tag. You use the angle brackets, the less than and greater than. All right? So as it says there, with a type collection, you specify the data type in angle brackets. Then you can only store objects of that type. And any errors it finds will be discovered when you attempt to compile. So in other words, if I had one of these generics and I said they were integers and I put in a string, or I left it blank, or I put in a number with a decimal place, it would immediately blow up. All right. So it says the next figure on the next page, that's what we're going to look at, shows 4 of the more commonly used type collections. And it looks weird. All right. List T, array list, sorted list, queue, stack. So let's quickly talk about what these are. Again, an array list is something that can dynamically grow and shrink as the program's running. If you can understand that, that's all you really need right now. If you want to be able to sort this type of list, instead of making a list, you make a sorted list. All right, and the other two, again, whether you think so or not, you know what these are. So imagine it's the first day of class. None of you have ever been here before. And what we're told to do is I'm told, okay, once you start class, tell your students to go down to the end of the hall where Justin is and get your picture taken for your badge and get your parking space. All right, and James happens to be the first one down there. So he's the first one in, so he's the first one that's serviced. Would you agree with that? Gabriel's the last one in line, so he's the last one in, so he's the last one who's serviced. All right, that's a queue. That's typically how things work. All right. On the other hand, a stack like they show right there, we don't have a cafeteria here, but you probably have all been to a cafeteria at one time or another. So the cafeteria worker comes in and he or she puts down a whole bunch of trays. They put them on one of those spring mechanisms. You grab the first one. So the last one that was put in there is the first one that comes out. Does that make sense? All right. So a queue is first in, first out. A stack is last in, first out, often called FIFO and LIFO. All right. So as it says there, a collection is an object that can hold one or more elements. The collection classes in systems.collection.generic use a thing called generic that allow you to work with typed collections. The reason, again, that this is important is it allows you to have dynamic sizing. So things can grow and shrink as the program is running. All right. All right. Typed versus untyped collection. As it says, the figure on the next page will show the difference between these. It says in particular, it shows that typed collections have two advantages over untyped. First, they check the type at compile time. So if you say that the type is int, it checks to make sure they're all ints. So that prevents runtime errors from occurring when the program's running. Second, they reduce the amount of casting that's needed to retrieve objects. All right, and if you find that confusing, believe me, it's going to get worse. Because when we talk about classes, a lot of this stuff even gets harder than it is here. But notice what we have. So here we're saying array list instead of an array. Array list numbers equals new array list. All right. Notice we've got a different using statement because this is a collection. And then we could say numbers.add, etc. Now this won't run because we've said it's a new array list and we're putting numbers in it. Now we try to put in a string. Does that make sense? All right. So I'm not going to reread this because that's what I just said to you. Those are the advantages. If you want to use untyped collections, you can edit the using directive so that it refers to the system collections namespace instead of systems collection generic namespace. With what you're doing right now, I'd say probably for the whole semester, we're not going to be using untyped. They're going to be typed. Now, could I be wrong? I'm wrong as often, if not more often, than I'm right. All right. Working with a list, as it says there, to create a list, you use the new keyword list. So we could do something like this. Now, when you do this, this is what gets confusing. Please look at this line right here that's in blue. Everybody see that line? All right. This says create a new list and have it hold 3 strings. The problem, or not the problem, but the thing is, once you put in a 4th one, it automatically expands. All right. Quite often when you see this, and this is why it looks weird, look at the example above the one in the blue. Quite often you don't give it an initial size. And many of the times when you do that, it defaults to 16. Again, it has to do with the way computers, basically reference things. But then when you reach the 17th, it automatically ups it by 16. But you can set it up that it starts at 100, and every time it fills, you add another 100 to it. It's up to you. You can do this any way you want to do it. And when you work with a list class, you use some stuff that we have not seen in arrays. Capacity, count instead of length, add to put a new one in, clear to clear them, contains to see if it contains something, insert to add a new one. All right, add adds it automatically at the end. Insert, you can tell it where to add it. Remove, to remove the first occurrence. Remove at, to remove occurrence at a certain index. And that binary search, which we talked about before, and sort. So here what they have is they have this list of strings. So you put in 0, 1, 2. It automatically gets, again, doubled. So instead of 3, it's 6. You reach 6, it automatically doubles again. So now it's 12. It reaches 12, it doubles again. So it's 24, etc. Does that make sense? So as it says, a list is a collection that automatically adjusts its capacity to accommodate new elements. The default is 0. You can change it to anything you want to or need to change it to. All right. As mentioned, this is probably the hardest thing we've gone over thus far in this class. So there's some examples in here on how this can be used. You can also, as it says, work with a sorted list. It says a sorted list is useful if you need to look up values in a list based on a key value. Well, if I wanted to know something and I knew what its price was, but I didn't know what the item was, and I had it sorted by price, boom, I could find it. Or the other way, if I didn't know what a price was, but I knew what its name was, and it was in sorted order, boom, I could find it. And again, when you look in here, most of the stuff looks similar, not identical, but similar to what we've already seen. You'll notice that in here we've got keys and values. If that confuses you, think about it like a dictionary or an index in the back of your book. If I wanted to find out what Q meant as far as C#, I might go to the index in the back of my book, look up Q, and it said page 857. So I go to page 857 and it says a Q is. So the key would be Q, and the value would be what's on page 857 or whatever. In much the same way, you oftentimes set these things up. Think about it. If that confuses you, a lot of times people will use these for like a list of states. MO, Missouri. NE, Nebraska. WI, Wisconsin, etc. So the key could be something small, the value could be something bigger. And it might be the reason that becomes important is now no matter how big the state is, and I don't know what the longest state is, the one that came up to me was New Hampshire or Massachusetts or something like that. But now I could store every state as a 2-letter abbreviation. So I could really minimize the amount of storage I was using. All right, but what I could show the user would be rather than MO, I could show them Missouri. I mean, a lot of times to people, MO, they might think that might be Montana, for example. All right. All right, and again, there are code examples in here. Then they go into queues and stacks. I already mentioned to you what those are. We're not going to do really any work with queues and stacks. All right. Now it says here, although you'll probably want to use typed lists whenever possible, figure 818 shows you how to work with an array list, the most common untyped. All right. So this is using a regular array list. Again, the types, it still has to be all decimals, all floats, or doubles rather, all whatever. All right. So the array list is a type of collection. As it says, it has the same properties and methods as the list. Now, what we are going to be getting into, for example, when we get to chapter 12, is we'll build like an employee object. And we'll say all employees have a first name, a last name, a social security number, maybe 5 or 6 different things, but they'll be different types. That's when this can really come in handy. All right. And if you say, well, I don't get it, you will when we get to that point, hopefully. And that's it. Now, before I let you loose here, give me 5 more minutes, because what I want to do, I thought that sounded interesting, so I was going to read it later. But these are the 2 assignments, the 2 labs for Chapter 8. So let's take a quick look at both of them. When are they due? A week from Friday. This Friday is, I think, the 12th, so they are due the 19th. You're going to hear this now every day of the week from me again, but remember, no class next Monday. It's President's Day, no class. All right? So let's quickly look at this. Look through this if you have questions. We've already talked about all this stuff. The new stuff is what's in here. What you have not yet seen is a parallel array. So imagine that I've got, let's just say that I've got 3 arrays, okay? One's got first names, one's got last names, and one has salaries. Are you with me? So we work at a company, and we're going to assume everybody has a first name, a last name, and a salary. Okay? So I could go in and I could create, for example, 3 different arrays. Let's say we've got 10 employees. So I could say string, bracket, bracket, first names equals, and I could just say like new string, 10. Then I could do the same thing with last name. Then I could do the same thing with salaries. We'll make it decimal. Does that make sense to people? Then I could come in and write myself a loop, a for loop. It doesn't matter which one of these, they're all 10. So I'll just pick the first one, first names, dot length. Then I could come in here and I could work with first names, LCV, whatever it is. I could work with last names, LCV, and I could work with salaries, LCV. Does that make sense? Those arrays are parallel arrays because I'd be working with them in parallel. So what's in there, that's a parallel array. All right. And you will see those. So as we go through this, let's quickly look at these problems that are assigned. Now, what I want you to do, and notice, all right, so the first one, really not very hard. It assumes here you've got 10 different zip codes. And here are your delivery charges for each zip code. So you put in a zip code, you click calculate, and it tells you the delivery charge. So what would you want to put in here? Well, first of all, when you look at this, all right, you may or may not agree with this, but you know what I'm going to do there? I'm not going to make these numbers. I'm going to make that a string. Typically, that's the way I'm going to do it. Because typically, you don't perform any mathematical operation on a zip code. So I'm going to make it a string. Plus, if you leave it blank, it's much easier for me to check for. All right. Or if I put in, let's say I put in 88888, well, that's not in here. All right. So I can just have a message pop up that says unknown zip code or zip code left blank or whatever. So there's that one. Then the next one, write a GUI app that calculates the cost of a resort stay. So what do you have to do? You have to put in the number of nights that you stayed. So the minimum would have to be 1, right? Does that make sense? There is no maximum. I mean, there are places, I actually thought of doing this. I know that right off of the interstate, there are a couple hotels that have weekend rates, and I thought of doing that when I moved here instead of getting an apartment. All right? But you could do that, so you can't really put a maximum on there. All right, but you put a number in here. You might check to make sure that it's a minimum of 1 and it's numeric. All right, you click calculate. So if it's 4, then you have to look this up. It's 180 a night. 180 times 4 is 720. Does that make sense? All right. Then the next one. Now this is probably the hardest program thus far. Create a searchable database for a video game store. It's not a real database. We haven't talked about databases yet. All right. But the user can search either the name of the game or the name of the publisher rather. So what are we going to have in here? Well, this should make sense to you. This is one of those times we'd use those three. We have 3 parallel arrays. We'd have a string array called name, another string array called publisher, another string array called price. All right, then the lookup isn't that hard anymore. So notice if we look up Call of Duty, it gives us the name, it gives us the publisher, and it gives us the price. Here they put in Warframe, which doesn't exist. So it just says not found. Okay. Then finally we do it again, but this is a searchable database for a movie library. All right. And it says, so how many movies do you put in there? That's up to you. If we do it, we'll put in like 5 movies. I mean, I'm not going to sit there and put in every movie there is. There is a database out there that if you've never heard of it before, it's called IMDb. It's the Internet Movie Database that supposedly has every movie since I think it's 1900 in it. All right, that would be silly for us to do something like that. Finally, the last one I believe that you have to do in here, write a GUI app that masks all but the last 4 digits of a credit card number. You may have done that already, but we didn't do it as an array. All right, and that's it for that one. The next one. Write a GUI app that can reverse the order of 4 numbers entered in by a user. So I enter in here 1, 2, 3, 4. What does it do? When you click reverse, it puts 4, 3, 2, 1 there. Does that make sense? All right. Then create another method called sort words. So we put in the quick brown fox jumps over the lazy dog, and notice what comes up. All right. It puts it in alphabetic order, and uppercase comes before lowercase. If that confuses you, go take a look at an ASCII table, ASCII. Next, write a GUI app that accepts the bids for an online auction. This one is I'm telling you, we may want to do this one together. This is a pain in the ASS because it accepts all these different formats. All right, so there's a lot of work you have to do in order to be able to do that one. Parse the bid and make sure that it works correctly. Finally, I think this is the last one. Write a GUI app that accepts up to 20 integers and calculates some stats. That's almost what we're going to do tomorrow. So I think that one won't be a stretch for you at all. Last thing, quickly, I'm going to show you what we're going to do tomorrow. All right. One of them I haven't written yet, so I plan on writing it while you're working today, because I've got a couple hours to work on it as well. But the first one that we're going to do tomorrow is going to look like this. Not that one. Where is it? There it is. The first one's a console app, and it's easier as you'd probably guess. It's a console app. All right. And the code, how much code is there? Not a boatload, 90 lines. Okay. But when we run it, it looks like this. Now, that might be hard for you to see, but it says the array in original order. Then we put it in ascending order and find the smallest element. Then we put it in descending order and find the largest. Then we add all of them up. Then we get the average. Okay? All right. So that's the first one that we're going to do. Then we're going to go back and, for lack of better words, almost GUIize that. And we're going to do this. I'm going to ask that you build the interface for this yourselves tomorrow. And I'm going to give you the names that I used, whether that's good or bad. This is something we haven't really looked at before. It's called a list box. And it just lists stuff. All right. So if I run this just to show it to you. So new numbers. There's 25 random numbers. If I click here, it clears the list box. And now I can get 25 new numbers. Make sense? All right. Here are those numbers in ascending order. Here are those numbers in descending order. All right. I'm going to go back to ascending. And I'm going to search. You'll notice that 51 is right there. So I'm going to search rather, and I'll put in 51. And hit enter. And it says it was found at position 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes sense? All right, if I search for 52, which is not in there, says it was not found in the array. Now, what's neat about this program, did you notice when I clicked this, it came up with this box? That's called an input box. Guess what? There ain't one of those in C#. What I have to show you is we have to go into Visual Basic and bring in a reference to Visual Basic into our C# program so that we're able to use that. So you're making yourself a little more meldable. You know, you're getting another thing in here, so to speak. And then finally, I can come in here and I can get the sum. I can get the average. Again, the lowest, the highest, the median, which is right in the middle, which in there is 51, the range, which should be 99 minus 4 or 95, and it is. So we're going to do all that. All I'm going to ask tomorrow is that you build an interface that looks somewhat like this, and I will give you the names. Why? Because it'll make it much easier when we put in the code. All right, if you use the same names that I use. Questions on any of that? So that's what we'll do tomorrow. And I'd like to do a problem with an array list if we have time to do that as well. All right, I don't believe you have any of your homework. It doesn't do much work with array lists, but at least we'll have been exposed to one. All right, so that's all I've got. Rest of the period is yours then.